So for each of the following functions, label them as increasing, decreasing, concave up and concave down, and give the left and right hand limit statements. So on A here, you can always tell by this is a positive log, and this number in front tells me that this is a negative. And I would draw both of these graphs. So positive log graphs look generally like this. Negatives will look like this. So I can tell a lot about that from these drawings, that this is increasing. Positive and increasing go together, which makes sense. If somebody's being positive, like it would bring me up, it would increase. And then from this drawing, this is concave down. And then for the limit statements, it's always going to be as x approaches 0 from the right. So this is the left-hand limit statement. So right here, what I'm looking at is as my x values get closer to 0, what is my function doing? That's what my function is doing on the left. I'm getting closer to 0, and I'm on the right side of 0. That purple line's on the right side of 0. So of my function, so of a of x, because my function is a of x here, I'm going to negative infinity, and then as my function goes right forever, my function goes up. So my function is going up as I'm going right forever. So for the other one, this is decreasing. Concave up. And here are some limit statements. So as I go to, so looking up here, as I go to 0 from the right side, so this purple line here, what's it doing? As I get closer to 0, my function is going to infinity. And as I go to infinity on x, so as my function goes to the right forever, I'm going towards negative infinity. So for 9, let f of x be negative 12 log base 13 x plus 33 minus 4, and g of x equals 4 times f of x minus 3 plus 10, and then find the domain. So remember, to combine these, I've got g of x is 4 times whatever f of x minus 3 is plus 10. So these are just transformations. The 4 is a stretch 4. The minus 3 in parentheses is right 3. And then the plus 10 moves it up 10. So I'm just going to go to the ones in the same spot. I'll underline them in different colors. So I'm going to multiply these numbers out front. So g of x equals negative 48. Because I'm doing this f right here tells me I'm doing all of these things to the function f. So I'll multiply the numbers in front. And log base 13. I'm replacing whatever x is with x minus 33. X minus 3, sorry. So x minus 3 goes wherever x is here. So I've got x minus 3. And then there was already a 33, so I've got plus 33. And then at the end, I've got minus 4 and plus 10. So it's going to combine to plus 6, okay? And then I can combine like terms in the argument, in the parentheses. Negative 3 plus 33 is going to be plus 30. And remember, so it wants me to find the domain of g of x. So remember the domain of a log. So for logs, the arguments must be greater than 0. So whatever my argument is must be greater than 0. My argument is x plus 30, so x plus 30 is greater than 0. If I minus 30 on both sides, I get x is greater than negative 30. You might also see it as negative 30 to infinity. 2 more. I've got if m of x equals, oops, that's in the way. If m of x equals e to the 4x, over 3 to the 4th. Find the x value for which m of x equals 9 over 8. So basically this is telling me to replace this for m of x. So I'm replacing that here. I'm putting e to the 9 over 8 where m of x is. So e to the 9 over 8 equals this 4x. I can multiply that. So I have e to the 4x over e to the 3/4. And just a reminder that when I have a problem like this, I can use exponent rules to combine these to a single e. Because my whole goal is to get a single e on each side and then use then use the inverse, which is log e or ln, to get x out of the exponent. So what do I mean? So here, I'm going to subtract these two exponents to make them a single exponent. This looks like e to the 9/8 equals e to the 4x minus 3/4. Now I can do ln on both sides, because ln e, because there's no number in front, just cancel out and the exponents come down. So 9/8 equals 4x plus 3, minus 3/4. So here, I'm going to add 3/4 both sides. And then to combine this, I'm going to have 9/8 plus 3/4. I'm going to do that up here, 9/8 plus 3/4, because remember, you're not going to have a calculator for this, so you got to get them a common base. We can make it a common base of 8. So I'm going to have 9 over 8 plus 6 over 8, which is 15 over 8. So up here, I'm going to have, I'm going to write it in blue. I'm going to have 15 over 8 equals 4x. So I need to divide by 4 on both sides. So to do this, you can think of this as keep, change, flip. I'm going to keep it as 15 over 8, change it to multiplication. And instead of dividing by 4, I can multiply by 1/4. That equals x. I multiply the tops and the bottoms together, the numerator and denominator. And that gives me 15 over 32 equals x. Last problem. Let me erase some things here, so I can see my problem. So if similar setup, it gives me what q of x is, and it wants me to replace this for q of x. So I'm going to replace q of x with 17e. But in this case, what's going to happen here is I'm going to have, I'm going to minus 3e on both sides. Minus 3e on both sides, because I need to get a single e on both sides. So because this is just e to the 1, this is just e to the 1, I can subtract them on both sides. That's the difference here. So that gives me 14 to the e equals 7e to the 4x. And because this 7 isn't attached to the exponent, I can just divide by 7. And that gives me 2e equals e to the 4x. Now, when I'm doing this, you can look back at your worksheet D on topic 2.13 for notes, like further practice on this. But I'm going to do ln on both sides. And remember, what happens is this cancels out and the exponent comes down. But on this one, it's not quite that easy because I've got a 2 in front of the e. So I've got to break it apart using log rules. And remember, this ln of 2 plus e can break into ln of 2 plus ln of e. And one of the reasons I want to do that is because ln of e, this is e to the 1, so the 1's just going to come to the front when they cancel out. So I'm going to have ln of 2 plus 1. ln of e is just 1. It's 4x. Divide by 4, and that gives me the answer is ln of 2 plus 1 over 4 equals x.